Hi everyone, welcome again to my YouTube channel Fitness Fit Computer Geek. In the last lecture of C programming course, I have shown you coding example on loops, where we have seen multi-level loops and show you some coding example on matrices. We work on lot of matrices. We have taken a lot of matrices, like we have done the codings on the addition of two matrices, addition of the even element of a matrix, addition of odd elements of the matrix. Now, as I have shown you in the last lecture, if you remember that the upcoming lecture will be the last lecture on loops. We hope the concept of loops have been cemented in your mind and you don't have any doubt, and you are going with the codes very easily. You're able to solve questions based on loops very easily. So this would be the last lecture. In this lecture, I will show you how to multiply two matrices and output that result. We will multiply the two matrices and then we will output the result. First of all, I will show you the concept multiplication of matrix. Although it is from the higher secondary courses, you might have learned in your 12th and higher secondary courses, but still I will just go through the basics of matrix, multiplication of matrix only, because it will be helpful to design the algorithm for it, and using the algorithm I will show you how to implement the algorithm and write our code on C language. Okay, so this is the last lecture on C programming course on loops, and from next lecture I will teach you pointers, the most important topic of C programming, C language. Okay, so without wasting any time, let's begin. Let's now just first of all let me show you the concept of loops of matrices, how actually the two matrices are being multiplied, so that you can get your idea and from how we gonna implement those real mathematical calculation in our code. Okay, so let me just open my Microsoft whiteboard. Okay, here I will show you how to do that in the computer matrix. So now let me now open new board. Okay, just clear the canvas. Yeah, create new whiteboard. Okay, so now let me just create my now netboard and just show you there. Okay, just open the pen. So let me just give you the concept of so suppose there are two matrices A and B. Let me design the matrices A and B. Okay, there are two matrices A and B. Okay, suppose let me just give it space here. So we have to multiply these two matrices. Okay, so assume first of all, so one more concept before going into the matrix multiplication and showing you the example. Like I just told you that not every matrices are multipliable. So what I mean by saying that, so matrix must be compatible for its multiplication. You might have read in your intermediate classes. So how are you gonna do it? So suppose the matrix should be Mn. Suppose the dimension of matrix is Mn n, M into n suppose, and the dimension of this matrix is something x into y. Okay, so for this matrix to be compatible, the column of first matrix must be equal to the rows of second matrix. Okay, so column of first matrix must be equal to the rows of second matrix. So why this is true actually? Suppose let prove this by contradiction. Okay, let me just prove this by contradiction. So let me assume that m equal to 3 and prove by contradiction. We are using contradiction, and n equal to 2. Suppose for the second matrix part, x equal to 3 and y equal to 2. So let's see, we are able to multiply this matrix also. So let me just design the matrix first. So what would be the matrices like? Looks like 3 rows and 2 columns, means it will be something like that, and the elements of the matrix will be suppose A11, A12, only 2 columns are there, A21. Hope you know this part from your intermediate classes. Okay, A31, A32. So this is the first matrix. So it is 3 by 2 matrix, you can see. Now suppose now let me design the second matrix. So for second matrix, let me just design the matrices. This is 3 by 2 matrix. So what will be multiplication here? So what will be element here? Suppose this is B matrix, so element will be B11 and B12, B21, B22, B31, B32. Suppose this is the matrix part here. Suppose how we actually multiply those matrices. If you remember from intermediate classes, we just took the row number 1 of first matrix and just dig into the column of second matrix. So this will be the column of second matrix C2. So how are you going to multiply? First of all, this will be multiplied with this. So it will be A11 into B11 and to forming the first element of a first row. So this is actually work, you know, actually if you remember from intermediate classes. So first of all, this will be multiplied and this element will be taken, first row second column, okay, element, and is multiplied with first row second column, and element, the added matrix will be A12 into B21. Now that you can see that the third element of the column 2 haven't got any pair, and it will be never be multiplied by any of the element of matrices. So if you take this row, it will multiply with and again this will, firstly this will completed and this will multiply with this 2 again this will be left out, and when this row will taken, and same thing, these two element will be left out. Okay, if you are getting the point, hope you are getting the point. So these two element will be left out forever. So because of this thing, these two, you know, now let me just do something else. So let me just show you another point here. Okay, so what you have taken earlier, I will just reverse this, both this. Okay, let me just design it for you guys. Okay, so what would the matrix, just unchain this, or you can reverse this part too, and let me show you guys, okay, how it actually works. So now x equal to 2 and make y equal to 3. Now let's see. So what would the matrix elements will be look like? So what will the matrix here? So first of all, this will be 3 by 2 matrix. It will remain same, just this will change, and x equal to 2 only, and the columns will just 3. Okay, so let me just write the element here. So first element will be what? Same as we seen, A11, A12, A21, A22, A231, A32. Similarly this, okay, this is actually 32. So similarly this B11, B12, B13, because there are 3 column, and B21, B22, B23. So now let me just multiply this matrix and see what's the difference. So how are we gonna multiply it? First of all, we will take this part and take this part row and row this column. So first element will be what? Let me just design big matrix here. So and let me just write it now. So first element will be A11 will multiply with B11 plus A12 is multiply with B21. So this is our first row, first column, and this is first cell. So again this will multiply with, you know, this part. Okay, so what will the result here? The second, we are into the second column now. So in the resultant matrix we will also shift to the second column, if you remember from your basic classes. A12 into B21, A11 into B12, and A12 is being multiplied with B22. Similarly for the second row. Okay, now we will take, for second row we just take row from the first matrix and we just multiply with the column of first matrix, second matrix. Okay, so A22 to B21, and the same manner. Okay, I have to design one more column here. Okay, I just, okay, there one more column left. So A11 and A11 is multiply with B13 plus A11, and you know, A12 will multiply with B13, and these two will be added. And now let's move it here. So in a similar manner, just fill this column. Okay, just fill this column to these two and these three. So now you can see the resultant matrix is 3 by 3, and actually now you can see that if column of first element is equal to rows of second element, then the matrices are compatible, because it's help to forming the pair, because each of the rows element of a row is multiplied with each of the column. So each of the column of second matrix must be equal to the each of the rows of first matrix. So in other words, matrix must be compatible. So this is the case here. So these two have to be always equal. So hope you get my point now. So now let's move on now. The matrix number A and matrix number B, the dimension of matrix must be compatible, which I have shown you. So if this is Mn, then it must be n, and it can be anything I don't care. Okay, so suppose this is M for so these two must be same, and the resultant matrix will be of dimension M into N. So suppose we get a matrix of C, so its dimension will be actually M into M. So for dimension part, these two will be added. So just remember these 2 points. Okay, it is like a revision class for some of the guys. So some of the guys already know this, so this is revision class for them, and some of might have forget it about, so I just explained it here. So this is the case. We in this way the C matrix will form. Okay, hope you're getting it now. We have gone through this part. So let me just take an example of 3 by 3 matrix, and let's I will take an example of here a 3 by 3, and for compatible part, you already know this matrix compatible. So just for explanation purpose, it is very easier for me to explain you that, and you can just change this to dimension to anything. Okay, doesn't matter, but these two remain. This part, column of first matrix should be equal to column row of number of rows second matrix. Just this case should be taken care, and don't care what else is the here. Okay, you don't care. So let me now just show you, and let me just take the example of 2 matrices, and let's just multiply them. So suppose the matrix is A and 2 B, and as I have shown you that its dimension will be 3 by 3. I am just taking for example sake. So it is a square matrix part, but it can be working to rectangular matrix too. Okay, and why I am saying rectangle actually, yeah, actually you can see it not rectangle but any matrix, but these two remain same, this and then this. Okay, so let's fill the matrix, just design the matrix A1 A. Suppose now let just start with 0, as we are moving to the coding part, code of this matrix. So I'm just taking for 0. Okay, A01, A02, A03, A10, A11, A12, A20, A21, A22. Similarly for B part, B01, B02, B03, and B10, B12, B11. Okay, this will be 11, B1, and B00. Okay, this will be 00. Sorry, 0001 and 02. Pardon me. So 0001 and 02. Okay, this mistake might happen, and okay, 12 and B20, B21 and B222. So these are the dimension. So now we have to multiply these two matrices. Multiply this matrix and put the result in C of matrix 3 by 3. Okay, or multi-dimensional array of 3 by 3, 2-dimensional array. So these two have to multiply and form the bigger matrix. So let me just design the matrix. So these are the matrices. So let me design it bigger way. Okay, so it will be not too tedious to fill. So just take this and take this. So when this will be multiplied that, so it will be A00 multiply with A and B00 plus A01 is multiplied with B10 plus A02 will be multiplied with B20. Okay, so I will require the entire canvas there to multiply these two matrices. So now we're gonna multiply these matrices. So and now first row completed. Now first row is just A11 01 multiply with B01 plus A00 actually, and A01 is multiply with, I am looking at second column. Okay, B11 plus A02 is multiplied with B21. Okay, and now second row will be connected. Just I will show you 2 row only. Okay, because it's not worth to show the entire matrix. Just hope you are getting the idea what I am trying to do here. Okay, so just let me write it. You will get idea from this itself. So observe this part. So now just observe this part only. Okay, let me just make the canvas visible for you guys. Are you getting anything how we are multiplying this? So you can see you have seen that, you know, this so A00 and A00, it is the first row, first column. This is the first, you know, first I can say. So you can see that A part, for matrix A part, it's just the row row remain the constant, because we are in the 0th row, so the row remain the same, but column is being changed. You can see that it's 1 and 0, and then it's 1, then it's 2. So here you can see that the row remain constant. So for first cell, row remain constant, as you can see. So row remain constant means if we make I as row, and row I will constant, and just j will be changing, so j will be moving, so j will be moving for j for column. Okay, so and for the B matrix, you can see that the, you know, column part remains same, whereas we are in the first column of the second matrix, so column remain the same, and we are in the first row of first matrix, that's why the row remain the same. We are taking the same row now, first row and that column, okay, as the column of second matrix. So here you can say for, you know, for this is for matrix A, and for matrix B, what is happening here? For matrix B, for B actually, what is happening? The column remains same. You can see, because we are working in the first column of second matrix, so that's why column remains same. So these are the observation remain constant or same, and in this case j is changing. So pause the video for a moment and think about your logic. Is it going to possible? All I am showing you to know you, so that you can implement the logic here. So in a similar manner, this too, and when this entire row is over, so you can see that row remains same in this part too, for the entire row. Okay, let me just get into the matrix part. Okay, so let me just work in the matrix itself here for few time, so that you can analyze it. So you can see that first row will remain same unless all the three columns, first column, all the three column, first column, second column and third column are being completed. Okay, so this form to first row and first column form the first row, first column, or you can see the first cell, and then first row, second column form the second cell here, row wise. Okay, row wise second cell, and in a similar manner, so in second row, first column will form the second cell. Okay, second cell column wise. Okay, hope you are getting it what I am trying to say. So second cell column wise. So what you conclude from this actually? I think you get idea, you might have get idea. And now again the column is changed here. Now again column changes, and but it will remain constant for this cell. Okay, you can see that. And same for B. Hope you're getting it. So for B part, it will just for second row, first column, so it will remain same as it is. So you're getting it, something you're getting clue from something, this or not? How are you gonna design our logic? Logic is important. Okay, or algorithm you can say. So what you're gonna do it? Is it possible to just design this using two loops, or we need third loop for it? Think about it. Is it possible to perform this matrix multiplication in two loop itself, or we need third loop, three loop? So this is the think about it. Can we just, you can see that simultaneously. Okay, so you can see that simultaneously a j value of A in the first row, observe this row only, this cell only, first cell. So I of the first matrix means the rows of first matrix remain same, because we are performing the multiplication including the first row. Only the column part changes, because we are moving, well, as we are crossing the row, we are also crossing the, as we are taking the first row, and the column including in that row are also being passed. Okay, so how are we gonna design a logic? So clearly we will need more than two loop, of course, because we are the value of I and j are changing simultaneously, means when we are multiplying the first row, means just let me write the first part only. Okay, And let me just write this part. Okay, A00 first column is multiply with B00 plus A. You will get idea from this part only the first 01 is multiply with B10 second and second row, and A02 will multiply with B20. so we can see simultaneously A and G value are changes, so we cannot perform this using a single loop only. Why? Because we cannot perform this in a two loops. Why? Because if you take two loops, suppose that the first loop is for I equal to 0 to n minus 1. Suppose the first loop is this, and we just take the second loop, and like this second loop is for j equal to 0 to n minus 1. So if we do this and just think about this. Okay, programming is all about thinking, not directly jump into the program, but you just have to think about it. Just write here C of ij plus equal to A of ij into B of ij. So can we able to perform this using this part and using two loops only? Just think about it. Are we able to do this or not? Let me just dial in it and see is it perfectly fine or not, or another word, we are getting this part or not. Okay, so Cij, first of all, I is 0 and j is 0. So first of all, so C of ij will stored when 0 of 0 will stored what, plus equal to A of 0 and 0, everything will be 0 first of all, and B of 0. Okay, it seems like it's working fine, but whenever after that the j value will incremented. Okay, so j will initially 0, and after the completion of this part, again, this is loop, it will end, and it's just go to the iteration part, incrementation part, and just make it to 1. And when j is 1, so this will immediately change. Okay, so this will change to 0, 1, but we are in the still C1 C00 itself, because we are working first row of first matrix and first column of second matrix. So that's why we are even in the same row, but according to this logic we are changing our row. Okay, so this will again result into A of 0 j, means j is 1, and B of 0 and B of 1. So here you can see that it's not working, does not give us the desired results. So we cannot perform this using two loops. Okay, it is not possible. Okay, not possible. We are not able to perform this using only two loops. So can we be able to perform this using three loops? Let me just see that and show you guys. Can we able to do this? Let me just write again. So C of 0 0 must be equal to A of 0 0 into B of first row first cell, and then A of 0 1 is multiplied with B of 1 0 plus 0 2 is multiplied with B of 2 0. So this is the case, this is the desired result we have to get it. So we find that we are unable to perform this thing using two loops only. So can we do this using three loops? Let me just perform this. Can we able to do this? So suppose that we just take first loop for I equal to 0, I less than, suppose n is number of rows, and I plus plus, and for second loop we just take for j equal to 0, j less than n, j plus plus, and just take the third loop here. Okay, hope you're getting it. For k equal to 0, k less than, and don't think it is very complicated, it is very easy actually. Okay, now suppose we write like this, C of ij, because ij value have to remain same. So let me just write, okay, C of ij. Why I am writing ij here? Because I and j value will not change unless the k value is being changed. So we will remain in the same row until the k is finished. So you can write here I, you can write here j, you can write here plus equal to, okay, doesn't matter. And now main thing, you have to designed for first row. What we going to write here? Okay, whether I should write J here or K here? Tell me, guys. Okay, pause for a moment. So hope you have think your logic. So now let me just show you. So A of a row value is changing because we are moving in a row wise. So first of all 0 1, and the row value will remain same because we are moving in row wise. So 0 1, 0 2, 0 3. So 0 value means row value have to remain same. So suppose if I write, so just do this part only. Okay, and you will what I'm going to write it here, just tell me, guys. Okay, just this part have to be mystery part. So if I write J here, what will happen? So, and if I write K here, what will happen? And so in this case, if I write J here, so J will remain same. Okay, remember that the row value remains same. So J will remain same unless this part is over, K will over. So means unless we cross all the column as K indices, the row remain same. So K value will only change. Okay, so I and J and K, and remember this part only when we are multiplying with the first column and column of second row. The you can see that when we are multiplying first column of second matrix, so this value is going to change, the row value is going to change because we are moving downwise. So downwise the row is been incremented, so its value is changing. So if I write K here, it will make perfectly sense now. Okay, hope you're getting this, guys. This is some logical, nothing else. K here and here, just write J. So let's see, try run it and let's see we are able to get this part or not. If we are able to get this part, then our logic is perfectly fine. So C of ij means first row is J, I is 0 and J is 0. It is perfectly fine. And plus equal to, why I'm doing plus equal to, because initially we just imagine that A of C of ij is even 0 and just increment adding the multiplicative value of each row being multiplied with each column and each cell, adding addition of each cell value to forming the first cell. Okay, hope you're getting it. And this is the logical part which I have shown the mathematical view, which just I am implementing the code here. Okay, so here will be J will be 0 and K will be 0, then multiply with B, K will be 0 and J will be 0. Okay, this is fine. So first addition is done, means we are getting the first row, first part of this matrix, and the first cell, first multiplication of two cells of corresponding matrix, we are getting it. So now addition part. So now what will happen? Now you can see that after this part K, after we are inside this loop. Okay, this is the loop only. So inside this loop we are we are just perform this operation and we will come back to the iteration part, and K has been incremented. So K will now, initially K was equal to 0, now K will become 1. So now what will happen? K is 1. Okay, and all the things remain same. So C of 0 0 actually, because I and J is there, 0 0 plus equal to, plus is this value is already in Cij stored, and equal to A of, it was J. Okay, it was J, so J will remain same, still 0, and K is becoming 1 now. K is 1 into B of K, K is 1 and J is 0. So now we get the second part here. Okay, A of 0 1 into B of 1 0. Now again K will incremented now, so K will now become 2, and again we will write this an equation 0 0 plus equal to A of K, J 0 and 2 being multiplied with B of 2 0. So now we get the third part here, A of 0 2 being multiplied with B of 2 0. So now compare this part with the logic we have written earlier. Okay, just compare it. So now compare this with the written logic. So is we are getting the same thing, B A 0 0 B 0 0, A 0 1 B 1 0, A 0 1 B 1 0 and 8 0 2 B 2 0, A 0 2 B 2 0. So we are getting perfectly fine. So this means our logic, which is this, is perfectly fine, and this is the basic foundation of multiplication of two matrix. Okay, so very simple. If you are going till now, you are following me and going through my explanation step by step, you will find it very easy. You might have found it very easy. So just this is the implementation. Similarly, if you gonna perform Now k will over because 2 and n is 3 here and k is 2 here. So k value is over now, and again it will end up, and the loop will go to the outer loop. And for j equal to 1 now, it will run again. So j equal to 1 means what? J equal to 1 means here 1 means C0, 1 means first. Now we are going into the first row second column. Okay, means what? 0 1 means first row second column or not? So again we have to perform this. C of, actually j part is now 1, so j is 1 and k is still 0, and we will perform this part again. For a equal to 1, it will now become 1. Why? Because a here j part and k part remains 0. Into b part will be, k value, so k is 0, and j part and b of j will be 1. So now I hope you are getting it. Now we are into the second row first column. Okay, second row first column means what should be the result here? So means C of 0 1, what should be the result here? C of 0 1 must be equal to C of 0 1 equal to plus equal to, write it, or just write it like this. So a of 1 0 may multiply with b of b of 0 1. Hope you remember this. This was k, this was j and k, then this was k and this was j. Okay, don't forget this part. Okay, so j value will remain same. So what will the next iteration? It will become a11 and b a11. Okay, because k will become 1 into b11, a11 and b11, and the third part is a, it will remain same, j will remain same, and k will become 2, a into b0, k will become 2, and it will, j will remain 1. So it will now fill the 0 1 column. 0 1 column means this first second part. So what was 0 1 column actually? Okay, hope you remember this. Let's just go back to our original matrix. So okay, here we go. This is original matrix. This has to be multiplied with this part. Okay, hope you're getting it. And now this is being multiplied now. This part is multiplied with this part. So a00 must be multiplied with. So yeah, that's the what I was trying to say here. So second row first column will be what? Okay, so I have done something wrong here. A00 is multiplied with a b01 plus a01 have to be multiplied with b11 plus a02 have to be multiplied with b21. So actually a value still remains same. You can see that a value is not changing. So that means, what does this mean? This means what? We cannot use j here. Okay, this was the mistake. We cannot use j here. So better to use I here. Okay, so if I use I here, then our logic will remain, then it will intact. Okay, so it will still be 0 0 and still be 0 0, still be 0 0. Only b part will change. Okay, because we are moving in a second column now. So b will be 0 1 actually, then it will be 1 1. Okay, second part middle column, and then it become 2 2 1. Okay, so the main logic is just use I here. Okay, so this is the fault which we find. So this is dry run in program. This is the advantage of dry run. So if you dry run in program, you will find that error. So this is the final logic. Okay, and there is no change in it. You can apply this and you will find that it will not change anywhere now, because it will not complete until the first row of first matrix is multiplied with all the columns of each matrix. So all the columns are over now. The j part will over, the all columns will over. Then we will move to second part, second row. second row, then it will be repeated like that. Okay, so this is the basic logic of coding. Okay, so now let's implement this in our code block now. Okay, this video is become too large, so I will show you in I was just one more video. Okay, one more video on coding part only. Okay, so it will be a very long video, so it will be very tedious to watch, so I will just make one more video on coding, and that will be definitely my last video. Okay, I'm always saying the last video, but because of time consuming part of explaining these topics, it's extended, so just wait for one more video, just the coding part there. Okay, I just discussed the thing here, so note it down guys, and we'll do the coding part. Okay, so guys, thanks for watching. So this is a continuation of another video. Well, I will show you the coding part, so see you in the coding part. Okay.